Picture two lines. How many ways can those two lines intersect? Well, these two lines intersect once. I'm talking about straight lines here. If I have a line like this and I have this, obviously there are a number of ways that those two lines could intersect. The green line, I'm going to say, is not a line, so I'm going to ignore that situation. Another way that I can have lines intersect is to not have them intersect at all. The only way you can do that is to have them to be parallel lines. Remember, parallel lines have the same slope. This means that if I rise one and I run one, for each line, you guys will never cross. So far, I've got two ways that lines can intersect. I can intersect once, I can intersect not at all. You could say that if I have this line and I have an exact duplicate of that line, and I take the second line and I place this line on top of the other line, we could say that these two lines intersect everywhere. Every single point on that line is a point of intersection, or an infinite number of points of intersection. All right, so we just want to dig a little further here. We'll look at the case where we have two parallel lines. Remember that parallel lines have slopes that are equal, and we know that parallel lines never intersect. So example here is these two lines here. Notice that they have the same slope. Remember, the slope's the number in front of x. So right away we know that these two lines are parallel. So let's plot these lines. So I'll start with the y-intercept of 3 for this guy, which is right there. I'll use my slope to plot another point. So we're going to rise -2, and we're going to run 1. There's another point right there. So that's our first line. So the second line is a y-intercept of 2. We're going to start right here. We're going to rise -2, and we're going to run 1. We have the same slope as our other line. So as you can see, those two guys, they're never going to intersect. The second case, we have two non-parallel lines. So these guys are going to intersect once. Remember, lines cannot intersect twice. They're straight lines. This guy has a y-intercept of 3, so we've got a slope of -2, rise -2, 1, 2, and we're going to run 1. So our second line, we have a y-intercept of 2, a slope of -1, rise 1, and we're going to run 1 to this point, that line, cross through this point and that point. So when we have two non-parallel lines, we know that they're only going to intersect once, and they intersect at what we call a point of intersection. And we like to write coordinates of the point of intersection. So when you're talking to someone, you can say exactly where that point is. In this case, it's at 1, 1, and you can see that on the graph. So we've got one more case here. So this is when you have two identical lines. I can look at the y-intercept of -2. I can start there, and I can use my slope, so I can rise 1, 2, run 1. Now taking a look at this line, it's not clear whether this line is the same because it's written in standard form, and I can rewrite our equation so that it's written in slope-intercept form. Remember, to solve for y, it would be easiest for us to just take our -y and bring him over to the other side of the equation. If I just rewrite it like this, you can see they're actually the exact same line. If I just sort of move this on top of the other one, you can see that they're the exact same. With identical lines, they intersect everywhere, so every single point that is on one line is on the other. And this was a very quick video, but if this video helped in any way, feel free to like and subscribe for more mathematical chaos. As usual, thanks for watching.